Hi, everyone. Welcome. Thank you for your patience. We're about to get started here. I appreciate you joining our webinar today. My name is Christopher Tull. I'm the Chief Data Officer for the California Data Collaborative. I'm here today at Eastern Municipal Water District. So you'll see there's a small group of us here in person and a much larger contingent of you all online. I'm going to just say a few words for folks who may be new about the California Data Collaborative, and then we'll jump on into our presentation. So there we go. For those of you who may not be familiar with the California Data Collaborative, we are a nonprofit coalition of water agencies here in California. And really our mission is to help water agencies do more with their data, to help them aid their operations, to support them with policy, and really to just be sort of a data hub for good for water agencies in the state. We were founded in 2016 to facilitate data-informed policy, and really we operate as a collaborative, bringing folks together, and like our steering committee chair, Jenna, who is.
I can
put you up on the screen. To prioritize common problems, identify issues that are relevant for our members, and help solve those, whether that's tools that we need to develop, or policy or research that needs to be evaluated. Or situations like this where folks, we really try to bring the community together to share knowledge so we can all learn from each other. So I don't want to talk too long because what you really all want to hear is cool data stuff. So with that, I would love to turn things over to our first speakers, Ryan Green and Rafael Ojeda with Eastern Municipal Water District. Take it away, Ryan.
You have to stop sharing. Probably the window or entire screen.
Entire screen, so
Yeah.
you can switch between apps.
It's the first time we've done stuff like this in this room on this computer.
Yeah, looking great.
All right, hi everyone. Ryan Green, Management Analyst from Eastern Municipal Water District, presenting with Rafael Ojeda, our Meter Services Manager. And we're talking about governed data to trusted action. Just a quick overview for EMWD. We established in 1950, we serve water, wastewater, recycled. Kind of unique in California, we do both wholesale and retail and serve a population of approximately 1 million people. Pretty large service area, 682 miles. And then we are one of the 26 member agencies of Metropolitan Water District. We have a publicly elected board of 5 directors. Again, large in having 620 employees and the sixth largest public water utility in California. Again, we do drinking water, wastewater, and recycled water. There's a breakdown of where we get our water from. We've grown quite a bit since in the last 25 years. We're up 122% in our service area population. While growing, we were able to lower the per capita water use down 50% from where we used to be. And we, since 2000, we've grown our desalination plants to produce more water that way and also increased our recycled water. So now moving on to some of the ongoing data projects that we've been working on. I wanted to talk about how governed data becomes trusted action. So to start with having a good data foundation, you need accurate, well-maintained source data, as that's the foundation of any analytics project. It really depends on what your project is, but that can be anywhere from GIS to meter records and service orders to billing information. From there, you move on to the operational use. where you put the governed data in front of the people that run the day-to-day work. It's going to be field crews, your analysts, your meter technicians, basically anyone who's going to be more doing the hands-on work. And then from there, you get the trusted action. So the higher up management people know that they can trust your data because of the governance and the work that's been put into the detail to get the right analysis done. Can help support, where to dispatch your meter technicians, which meters you need to prioritize to get replaced or fixed, and who gets assistance out of your who gets the most assistance out of your customers.
Sure. Okay, well, hello again, everybody. My name is Rafael Ojeda. I'm the meter services manager here. A little bit of my background. I've been at the meter department for 20-something years now, hard to believe. And I actually started out here as a janitor before that. And so altogether, I've gone from janitor to manager in over like 25 years now. My first job in the meter department was a meter reader. And in those days, we were manual meter readers. We did have a little subset of the population as a drive-by radio read, but mainly we had a bunch of manual load runners, in the streets as meter readers. In those days, we actually had a platform fabricated to the sides of the truck, and we would hang off the side of the truck, and we would visit, thousands of meters a month. And so been around since those days. And then during the evolution, as we implemented what we call FlexNet, the AMI meter reading system. So I was part of one of the first change out crews, experimenting with the programming as we first started implementing and getting our wings, so to speak, as it comes to AMI metering. So yeah, with the evolution of the different types of meters, and seeing all of the growth in technology, wanted to share today and show how we utilize the dashboard developed here out of Power BI. My colleagues and I have been working on this for, what would you say, about a year and a half now. And so, yeah, just mainly looking to show you, can you pull up the dashboard or? Oh, okay. Okay, so yeah, we'll do the live demo afterwards. When we get there, I like to show you all the ins and outs that I do with the dashboard. So yeah, we utilize this on a daily basis, daily activity reports and KPIs, key performance indicators. It's a really useful tool. And where we're going in the future, I would like to see us, grow a little bit more in terms of showing more details, more drill throughs. Examples are average days to close service orders. Does this meter meet the service level agreements that we established? Work order versus available meter technicians is a real interesting thing to look at there. We can frequently say, we often do say that we don't have enough time, but we can never say that we don't have anything to do. In this game, there's always something to do. So that data is going to be interesting to look at. The number of meter communication failure alerts is a crucial one. We want to ensure that service level agreements are being met, that those bills are going out on time. Being that the meter is the cash register of the system, we want to make sure that we're upright and current, because we don't want to mess with people's money. And then the continuous usage details and drill through functions, that's another huge one for us. We have a setting right now that recognizes 7.48 gallons every hour. So basically a cubic foot detected every hour over 48 hours is going to trigger an alert. And, we're going to establish that so that we could, address those accordingly.
Another dashboard that we're going to cover in our live demo shortly after this is our pilot district meter areas, our DMAs. kind of modeling after Elsinore Valley. We're trying to pilot out our own DMAs, and reason I included this one is we've learned one of the big key parts of any data development for a report is the data governance. What we were looking at a site where we believe the pressure relief valve was somewhere on the map. So we sent out our field crew there, and it turned out it actually wasn't there, and it got moved after new development had been installed. So they moved the temporary pressure relief valve into a permanent area, but the GIS system didn't reflect that. So obviously the map that we have in office was not showing us correctly where that pressure relief valve is, which kind of taught us a lesson of got to make sure the data is accurate before we start just building stuff in Power BI and hoping it's right. This dashboard has been and hopefully continues to shape decisions about where district system meters need to be placed in order to correctly determine where water is traveling through our system, which should give us a better look into our water loss. And then the last dashboard we're going to talk about is our CARES program, which is we currently offer Help to Others, which is a low income assistance program. Each customer can receive up to $215 once a year. Currently, we're using some data to look and see if we should scale this to household size, because maybe someone in a 2 household size shouldn't be getting the same amount as a 8-person household size because we know they use more water. So the dashboard has allowed staff to analyze that. We also want to look at if we can prevent disconnections for our low-income verified customers. Through SoCal Edison, we get a list of people who are enrolled in their CARES program, which is the low-income program. And we want to determine if we can utilize that, knowing that they're low income, to try to give them assistance prior to them being disconnected. And then lastly, we've been using this to explore how we can link this financial assistance to conservation program. Due to our budget-based rates here at Eastern Municipal, water costs grow pretty quickly depending on which tier you're in. So if we can limit the water you're using, you're less likely to be in those higher tiers and hopefully give some of those low-income customers less need for assistance, and we can make more bang for our buck per se and help more people that actually need it, not the people who are just using more water. There's our contact info, and then I'll transition into our live demo.
Right. So what everybody should be seeing here, this is our landing page of what we refer to as our meter count page, and the upper right hand corner you're seeing like some indicators up there. You see our meter population. We have 183,000, almost 184,000 meters in EMWD. That's our total meter population. And so this is right off the bat, like an example of a key performance indicator we have set up here. Notice how it shows 99.5% of those meters are AMI meters. So on a little side note here, an active project we're working on, that 0.5% that we still got to make up here is some of our larger meter applications where what I would refer to as foreign meters are in place. That is, these are meters that are not compatible with the census protocol system. And in order to get those meters on the system, there are some added devices that we can do with maybe some updates to the approved materials list down the road. Discussions in-house are what we have right now to get that. So, you know, as we plug away at that, this landing page, I'm hoping one day soon, maybe a little bit longer, but I will see that move to 100%. And then that will enable the streamlined data, right? All the meters in the system into here, and now one spot, one stop, we'll have everything in there. We also just quickly display there our most sophisticated meter. That is these what's known as the Ally meter. You know, they offer pressure and temperature monitoring on them, but most importantly, they offer the remote valve actuation, so we can reduce water down to like a quarter gallon a minute, I believe it is. And then we could also close the valve from the headquarters through the regional network interface. We could send a signal to it. Usually that happens within the matter of minutes. Sometimes they don't actuate, and due to our topography, our system, I guess it's a good time to talk about what we have there. It's we have a tower gateway base station. It's known as the FlexNet system. We have 22 towers set up throughout our district. We strategically place them out on after we perform what's called a propagation study, analyzing the topography, the high spots, and the thing where radio frequencies can have difficult traveling through. Yeah, the way I equate it is very similar to like tuning into your favorite radio station. We too here have our own unique call letters that designate us. It's a radio cell technology. And these 22 towers are overlapping. They're working, and every day in the invisible realm, we're broadcasting reading. Every hour, the meter and the register, that is the register and the endpoint or the smart point, the FlexNet MXU, they communicate. And then every 4 hours, we broadcast those blocks of reads into the regional network interface, or otherwise known as the RNI. We also have then at that point that RNI links into 2 other systems, one being the meter data management system, the MDM. We utilize a product called SmartWorks Compass, a Harris product right now. Then we also weave into the customer information system, which is we refer to, you guys have heard it to probably the Kayenta system. So those three systems I like to equate it like a cord woven together, a braid, right? So they all three communicate with each other all the time. But it first starts with that field logic programming that we as meter techs do in the field. And so, that enables those allies to be able to work. But notice our number, there's 691 number of ally meters, just a drop in the bucket. Later on, I'll explain how we strategically deploy those, utilizing some information that we built into the dashboard. Is pretty cool. Then I also list there, just at a quick glance in the upper right-hand corner, the 284. That's the active live number of temporary hydrant meters out there. Our hydrant meters aren't just any regular old hydrant meters too. We've also integrated in the Metron water scope platform. This is a cellular type of meter. We're able to read these meters just like how we do our census meters, charts and graphs. They monitor them from the platform, hourly intervals. They're all there. The water scope platform is pretty cool too. It has some great bells and whistles to it. We've just fairly recently, within the past 6 months, completed that integration, and we're live with it. And so the other thing I like to display is how we have all kinds of really nice options here to set up. So what we're seeing here is this total meter counts. And first of all, we're on our route numbers. So there's an array of different, what we call route numbers or book numbers. Billing cycles is another term you'll hear. And so from the AMI system, we have 17, and that's where all of those big bar graphs are showing there in blue. Those are our AMI routes. And we got it sorted now by the number of meters per route. So what you see there is like, it's kind of difficult to see. I think it's like about 18,000 or so. Maybe I'm not seeing that too good. My eyes need some improvements, but anyways, yeah. So you see, every day of the month, we're billing thousands of customers. The great thing with our FlexNet system too is how we're virtually all FlexNet, and every single one of our residential customers is on FlexNet. So to that degree, we could say we're 100% AMI. So the beauty with the FlexNet, our AMI system, is it gives versatility to our customers. These customers, in the past, when we were manual road runners, meter readers, they were fixed at that time of the month when we went to visit their house. That's when they got their bill. They had no choice. But now, because we read the meter every hour, because we got the charts and graphs that monitor it, because we have this FlexNet system, the customer has the ability to choose any day of the month they like to get their bill. And so, yes, we have 17 billing cycles. The other little small numbers to the right are the other ones that we have woven into it. Some of them are given a generic original. Once we develop a service before we install the meter and program it, they get set up into just a basic book number there. The other ones are field maplets, which is like what our operators, it's a system our operators use, it's called the spatial wave field maplet. And our operators, they go throughout and they too have their meter readings and stuff like that. That's basically that 0.5 that I still got to make up into AMI. So yeah, that's what this one displays there. That's our route number breakdown. But we developed all kinds of
question.
Yes, sir.
So like route number, I always think of like a situation like that. The meter reader goes and reads the route. So with AMI, is it kind of a holdover from the past system that you still have the numbers, or is it?
Yeah, I would think of it as like the
Legacy.
day of the month. Like, so the first business day of the month, we would refer to that as book 1001 in our situation here.
Yeah.
So that's like the day of the month that the bill would go out and out the FlexNet system. That, or you could also think about it, that's the day of the month that we interrogate the meter to send the bill information from the RNI into the customer information system. Yeah. So, yeah. And what we're seeing here now at this point is our meter type code, which is brought in from our customer information system, right? Otherwise known as Cayenta. And the type codes, you see the vast majority of our system is what we would refer to as a 4-dial. Our type codes here are defining the billing dial. That's the method to our madness here is we define the billing dial. So what we're seeing there is a vast majority of something like 125,000 or so, like, right? Yeah, so 125,487 4D. That's that 4-dial. So that's basically us programming in the field, telling what every dial represents, and then our customer information system ingesting that and understanding where to apply the billing unit. So a vast majority of our meters are 4-dial. The other ones are 5-dial. And that's what we're displaying here. So all this other jargon actually means a lot of stuff to me, because we not only have a unit of measure in cubic feet, what you're seeing there displayed on the left, the thousands, hundreds of thousands of meters to our 4-dial cubic foot unit of measures, but we're also in the acre foot unit of measure game too. And that's what all these other numbers to the right specify here. What's great about this, at any given point, I want to understand everything, I could right click on it, drill through, and we could get to some great detail here. And
Yeah, with high,
Like that high to get rid
the
of that.
blue, yeah.
there it is. I can't get this mouse down.
Yeah, the mouse is fun.
Let me talk to you.
Yeah, so I'd like to see about that.
So yeah, so you see that I'm a little bit hesitant to go there because I don't know if I can go back with this mouse, but yeah, see what we see here is the drill through 125,000, just like that, produce. I can export out of here, sort, pivot table, do all kinds of great stuff here. It's great. So that's
What would you typically, would you be looking for like problem meters? Or would
so
you be-
here at this point, like I would be looking to, yes, and there are many other reasons there too. So like one of the things is like, yeah, if I wanted to drill through, if I didn't think one of the meter type codes was appropriately applied, right, I could go over there, I could identify the location number, put that into the customer information system, go to the meter tech tab, making sure we have all the right encoded numbers right, making sure we have the right codes right. So yeah, we use that as a data cleanup, but where I'm going in the future is going to show you more of that data cleanup piece here. And so, yep, we could break it down by size as well. So you see the vast majority of our meters in our system are that residential type of 5/8 inch meters, 132,000 of the 184 approximately 1,000 meters out there are this 5/8 inch type of meter. And we go all the way up to 48 inch on our system. And so, yeah, all of this at any given time, I could drill through and understand what every meter size links to in terms of location information and account information. It's all some really useful useful things here to look at. We then meter make codes is another one. And this is another interesting thing. And it's kind of what kind of makes me different and unique to other people that just come in to do this job off of the street. I, being the one who toiled in the soil, who's been around and seen the evolution and, I actually worked on very many of these meters with my own hands. I understand what all these meter type codes are telling us here. And that being said, talking about addressing specific meters, I know that the census ICE type of meter hasn't entered in through our warehouse in over 15, 16 years now. So this type of meter, when we first started, we had these meters. Remember, I was saying we were manual meter reading, but we were also drive-by radio reading. We went through and ultimately retrofit meter bodies that have been in the ground for a long time. These meter bodies, they were sitting in the ground already now at this point, hard to believe, 20 years. And so this is a really useful information piece for me to get into. And when I know that I got 104,000 meters that are going to need to be addressed here, we're actually now in the place where we've already deployed. We're looking at a redeployment now. So we're actually looking to upgrade, update, because the typical lifespan of the meter is 15 to 20 years. The tendency of the meter is they tend to slow down. So in our future, we're going to systematically address these, and this dashboard is helping us tremendously be able to focus on the specific ones. We also, when we were developing this dashboard, we discovered that our previous system did not account for set dates really accurately. So I'm going to drill through here to show you. So yeah, here's all the 104,000 census ICE meters that I know are old. And if you see in the upper right-hand corner, it's a little bit small, I know. But we end up, and I believe I sorted through the oldest. Now in the upper right-hand corner of this table, you'll see the set dates. There you go.
Sorry, those online, the mouse in this room is not, so does not want to.
So while he's doing that, yes, this dashboard helped us realize that our previous system didn't accurately track set dates proper. So as maybe you click the set date to ascend our DC.
Hide the pages too.
Okay, cool. Perfect. So what you're seeing here is, look at that set date for that 3/4 inch census ICE meter on 7th Street on the top row. It's that set date is showing in 1905. So interestingly enough, as we learned from the beginning, our district was established in 1950. And another interesting fact is that we didn't have AMI meters up until like the early 2000s. And so, yeah, obviously, you'll see this is a perfect example, I believe, on how, the data is going to be touching the field, and both are going to improve once we address each of them. So, for instance, now that I know I got to systematically address 104,000 census ICE meters out there, once we change those out, we're not only going to improve meter accuracy and have new meters deployed, but we're also going to improve data by bettering our set date information. So right now, strategically targeting this set of it's to the tune of about 3,000 meters are in errors as we've analyzed these set dates, and those are going to be some of our first targeting accounts to exchange out there in the field. Would you go back to the main? Maybe one more. Perfect. Okay, cool. So yeah, so you're seeing how this is all coming together. Yeah, these are all of our various meter types. We have everything from a master meter to a Badger. We have some Neptunes. We have some Camstrup we're deploying out there. But we're predominantly in the census metering game over here. Location classes. Now see how I can even break it down again, once again, you see like the vast majority of our system is this, it are these residential type of meters, 170,000 of them. But yeah, if ever somebody comes to me like, hey, how many wholesale meters do we have and where are they at? Well, simply right here, we'll drill through those. And I just got to get on that little line there. So there you go, 31 wholesale meters, drill through those, and we can see them also. Very useful of all of our location class codes there. And then lastly, on this page, I'll show you, we could break it down by city and know how many meters are in every city. Pretty cool. So that's all on page 1. Meter query. Again, this is very cool here, and I use this all the time. So just the other day, here's a perfect case in the example. Just the other day, I wanted to understand how many recycled meters, how many recycled temporary location meters. So here you see our really nice drop downs. We'll start on the right. So how many recycled meters? See how I have that all selected from the drop down. So how many recycled meters in the temporary location class code? So we'll deselect, come down. So not only how many recycle meter in the temporary class code, but there's a particular meter make I wanted to look at because I had a programming concern. I'll deselect. I wanted to understand these micrometer meters that we're working with. I had a concern about programming. Well, just like that, bam, all 79 that are deployed in the system generated. I can go line by line and look through each individual one by comparing the field logic programming to the setup in the customer information system. I could export and I could also deploy them into the field using our mobile workforce management system. Our guys are able to complete service orders using iPads and iPhones now through a mobile workforce management system that this dashboard also points to, which is what we're referring to nowadays as ClickVest. So yeah, this is the meter query page, and it can be used in all sorts of manners here. So once again, a very useful tool. Open orders, this is now getting into my daily activity report. So every day, I'm reporting how many orders are open out there. And this is as of, earlier this morning when I refreshed the report at 6 a.m. this morning, we had 1,167 service orders pending. And we got them all broken down. Here you see it sorted from the highest to the lowest. And just once again, if I wanted to drill through it individually, I could just highlight and hover over this and get my understanding of what each individual one is. And just for the clarification piece, these end reads are what we refer to, and this occupies a good amount of our time as meter service technicians. These end reads is a code talk that we use for non-communication meters. These are the ones that don't communicate for various reasons, whether it be our gopher, our nemesis out there chewing up our wires, or it's a product issue. There's some issue, disconnection, moisture intrusion. And so that's what that category of service order represents there. But yeah, you see right now we have off with consumption there in the next column over, check for studs. Disconnections, that occupies a big chunk of our time there. And that actually is going to lead me to our next page where, so first of all, disconnections for non-payments is what that stands for. We use the term DISCO. The disconnection is something that we end up spending a lot of time doing. There's a process with it. There's an assembly bill, state assembly bill that states that we got to give a notice before we can shut people's water off. So this disconnection, actually, by the time it comes to us, it's like about an 85-day hard to believe process. And by the time that disconnection order is fed to us, we're also at the time of dispatching the service order, we're sending a text message to the customer, letting them know, hey, between the window of 8 a.m. and 2 p.m., you're subject to be turned off for non-payment. Well, throughout the day, various interactions and transactions take place where the customer squares up, whether they're making a payment arrangement, a payment adjustment, or a pay in full, pay in partial. The service orders will disappear from the field technician's order queue, and this system will track all of that. But there is times where, man, we're rolling to a property numerous times, and it's causing what we call truck rolls, right? We got it calculated. Well, what we have here is our closed service order report, and as seen in the upper right-hand corner, I could adjust the date range. So right now we have it set up just to look at year to date, right? And then what I could also do is I could break down and understand each individual type of service order. So back to that disco point, we have what we call our frequent flyers, right? This is, again, me going even back to the very beginning when I first started talking about the Ally meter, our most sophisticated meter, right? The meter with the valve that we can shut off from the headquarters. Well, all this is going to come together. If I touch on disco, I see how many duplicate locations are appearing there. That is, how many times did we go there? So if I'm filtered on disco, then notice here we have this indicator, this meter flag, this Ally meter flag, and see how it's saying, yes, it has one, or no, it doesn't. So this is a real useful tool for me and the crew to again, strategically deploy more expensive, and let me say that too, these meters are about 3.5, 4 times more expensive as a regular meter. So we gotta place them out there wisely, and this is a tool that helps us do that, really effectively. So we could actually, in these location numbers, we could drill through. So like this one right here, and again, it's not only showing us how many. There it goes. So it shows how many service orders and how many canceled and how many closed. So this one has had 7 disconnections in this year to date, January 1st to today, and then it's had 7 reconnections. And so obviously this is a prime candidate for an Ally meter. From this also stems all kinds of return on investment information that comes. It's great. This is great. So that's a perfect case and point and an example how we would use something like this to, again, strategically target. The other thing we could do is same thing like on end reads. So when we do these no read found non-communication service orders, it should be like one of these one and done type of things, right? Where we go there, we correct it. But sometimes, it could be a mistake program, it could be a product issue, it could be a bad setting from anywhere between the meter data management system or the customer information system. Well, this is another good example of like a key performance indicator. So why are we going to this repeat times, and so we could expand out and see why that end read was there, and I could even get into the individual technician using it as a coaching opportunity. So it's all, this is all a very useful thing here. So from not only understanding year to date, but on the day in and day out, how many orders did we complete yesterday, and so on and so forth. Then we can come into this closed service order query.
Mouse said, nah.
There we go. All right, there you go. And again, this is just another really great breakdown for me. I can define all sorts of all of our service order types. I can tell it multiple at a time or just a single one. and break it down by the makes and the sizes. We could see the individual technicians, even all the way down to the sizes, the addresses, and I could use this in many ways. So yeah, that's about all I have to say about that.
Yeah, I have a question. So what are the data systems that are underlying this meter dashboard? Is it just like your meter data management system or?
No, this is using our CIS system. So it's using Kayenta, it's using Clavest, it's pulling data from MeterSense. The data that we've structured in our data warehouse.
Okay, so are you like joining all that data up like in a synoptic model or how you're?
Yeah, so I'm not doing any joining back on the warehouse. When we bring in the model, we build the model in Power BI. We do all our thing.
Awesome.
All right, so I'll go ahead and move on to our, like I said, very pilot DMA project, still a work in progress, but we wanted to show kind of how data governance can play into what you're looking at when you see your data.
Good teaser for you guys.
We're excited to see what you have.
Four.
Oh, do we have four?
3 or 4.
Okay, so what we're seeing here is what we call our Avalon DMA zone. This is an area that we took over from City of Perris. So it was already a closed loop system. 4 wells feed the booster pumps there, or feed the tank there, which then goes into some booster pumps, and then get distributed out throughout this little neighborhood right here.
If I may, real quick, and a fun fact about this particular neighborhood is, so this is an inherited section. We just took it over from the city of Perris that used to run this water situation out here. And they were all manual meters. So in this little residential section here, it's an isolated section where it's only, like Brian was saying, 4 wells go into a booster plant, but all of those residential meters, they're all brand new iPros. So that's an interesting fact.
Yeah, so like Rafael mentioned, they're all brand new. So it was really the perfect scenario for what you would want to see in a DMA, a closed loop system. So we know water's not exiting from this zone to any other zone, and brand new AMI meters. So they should be reading perfectly.
Should be.
Yeah,
Exactly, should be. And you can see here, we have our little date filter, so we can come in here and see, for that time range, we're only seeing a 4% loss, which is, I think, really good for that area. Eventually we want to get into translating that to dollars for water costs, but again, this is real high level. While we've been looking into some of this stuff, we've been trying to look at how we can use not only the AMI data, but the SCADA data also with it, with looking at the pumps and seeing what the SCADA data is saying compared to what the AMI is reading. And also, I don't think we have it on this one, but certain production plants, we have like pressure values and stuff on there, so we can look at that and see how that's being affected. Here you can see that we can go through and look at it by date. So if there was a date that we wanted to really drill into, we could go in there and try to see what's happening by date, which would then get us to, more of an hourly level, so we can see our date timestamp and go hour by hour for what's being used and what's being produced. So again, this Avalon area was really the perfect scenario for us, just due to have it being brand new meters and it being closed loop. Quail Valley was kind of our next big venture we moved from there. You can see it's quite a larger zone, a few different zones next to it. And this is where we started running into some of those data governance, I don't want to say issues, but tasks that we came along. The first major one that we noticed was there's a lot of pressure relief valves coming from this zone to another. This one is not a closed loop system. So obviously, if we don't have those pressure relief valves metered, we're not gonna know what's exiting that zone. So some of that work is actually still in development. We have one, you can see it's notated by that little hexagon right there. So we installed the meter there. Now we pretty much know anything that's going from our tanks up here down into the zone to the left. So we were able to get that kind of sub-meter per se and look at the values in that area. Which we went ahead and did that, and we still weren't seeing values we'd like to see. We're still seeing what we consider loss. Trying to figure out where the water went. So there was there's one right down here.
Yeah, right there in the.
So then we moved into this one and we said, okay, well, this is a pressure relief valve here. Water can be moving through there. So same system with the same process with the help of the meters guys. We went and installed one there. And we're now tracking that as consumption through that zone because we know water is exiting that zone from where it should be coming out of the tank and staying in the zone. So we counted that as consumption. And then coming into, sorry, here we go. A little bit more.
So that's the plant, and they now go south to Long Valley a bit more, right there. Yeah,
Right here.
yes, that's the big one, and the old one is out there in the corner. Yes, where it was.
Okay, yeah, so while we have a task force, so while we're in one of our task force meetings, we've been discussing about the team of where this potential water loss could be coming from, where this water could be exiting the zone. And we identified this as one of the areas. It actually turned out Raphael had gone out there and he was trying to determine, what type of meter size and if we have a straight run requirement for the meter to go on there. And it turned out that it was in a completely different zone, or completely different part of the street, which is marked as a different zone. Which kind of led to the ongoing discussion of making sure our GIS data is correct because obviously you can see that this is not where we had originally thought it was. And just looking at our aerial imagery, it looks like there's nothing there. Well, recently we've had new development that's finished out now. So we wanted to reevaluate and see, okay, well, is this in the right spot? And then is this in the right pressure zone? Or do we need to readjust these zones and make sure that we're keeping track of, this zone is the correct one and this one's the correct one. So we can track which water is leaving which zone and not just guess and say, well, all these houses should be part of the zone, but they're not. Do you have anything else you want to do?
No, still a work in progress.
Do you want to show our bad boy?
Oh, yeah.
No, I don't. It's not
Oh.
this one, yeah.
So we had, ironically, right before this, steering committee meeting, we had our bi-weekly meeting on TMAs. And so, 4%, we're like, woohoo, 25, we have one that's in the 80s. And so we're like, so we're trying to figure out what's going on with that one. But one of the big takeaways beyond just not knowing where assets were, are they in the right zone? There was also the manifold that was not that old that we identified would probably need to be replaced sooner than we would have thought for our asset management software. So it's this I don't know, gazillion and beneficial thing. Thank you, Elsinore Valley, for giving us ideas and things. We're finding these things okay, well, we know this asset's not in the right spot. Okay, we need to make sure that's updated. Well, then do we need to update our pressure zones in our system? That's another thing. Is this where the water loss is? Can we make sure and identify where it is better than we're doing? Also, our asset management software may not be the only indicator we should be using. So it's really just this ongoing thing of learning more and more about our system and, kind of cross-verifying our other systems that we use, other softwares we use as accurate as they need to be. Because ground truth's a lot more than asset management softwares are predictive. They just go off of industry standards and those kind of things. This is showing us actualities. So,
Like Jenna
and
mentioned,
ground truthing.
the one that we were looking at this morning is not on this version of the report, it's on a development version. But we are seeing upwards of 8 million gallons of what we would call loss in that area. But the operations team said, oh, well, there's a lot of zone splits right there. Let's check if those are open. And obviously we had a discussion this morning.
Yeah, it was like this morning at 9.
We're not sure what's
For an
going to come
8.
out of that, but operationally, it's something that they didn't had noticed before, and they just said, hey, we know this tank's dropping at a consistent level. Can you guys go check it out or put it in your DMA and see what happens? So they said they're going to look more into that, and they think they know what it is, but we'll still more information to come on that. And then I want to move on to the last demo that we're going to go ahead with, and it's
The fun stuff, some less depressing water loss money stuff.
So like I mentioned, we have a internal low income assistance program right now called Help to Others. And currently a customer can call in and say, hey, I need help with my bill. And we'll send them to a third party. And it's up to like a 2-week process of going through and getting them tax documents and doing all this stuff. And then for the third party to come back and tell us, we verified them as a low income customer, go ahead and give them the $250 credit, which at that point, if 2 weeks has passed by and you're about to get disconnected, tomorrow, it's not going to help you. So this dashboard is addressing one of those issues. The second one being one of our managers wanted us to look into is the $215 for everyone, the right scale. The goal originally was to cover 2 full months of bills to get them back on their feet. So she had brought up the idea of looking at it by household size, or what we call block factor. So you can see here for a customer who pays water and sewer, they're only paying on average $92 a month if they have 1 to 2 people in their household size. Whereas block 4, they're paying $166 a month. So if we were to scale that out and cover their full 2 months, we would want them to have 320, whereas these people should only get 180 because they on average, they have a less bill size. So we want to help out the people who, we want to give them a scaled assistance, not just say, this works for everyone, go ahead and take $215. Going on from there, we have the CARES disconnects. So like I mentioned, in partnership with SoCal Edison, we get a list of their low income customers who have gone through their program. And we do an internal matching and on name and address and match them to what account number they would have in our system. And we're able to determine the low income customers that we have matched. We want to look at how many of these customers get disconnected. And you can see that this is year to date. We've had 4,200 disconnections so far, and around 27% of those are low income customers. And I don't have the exact number, but I think the low income customers only make up around 19% of our service area. So you would want that, you would hope that numbers kind of scales together. So it was kind of a flag that there were more disconnections than we had expected from them. Another thing that we want to look at alongside with that is, does household size matter if you get disconnected or not? You can see, obviously, block 3 has the most disconnections, and of course that could go along with if the scale of people that are in each block. But that was just kind of a quick thing we wanted to look at, is which group should we be targeting for that type of stuff. Moving on, so like Raphael mentioned, we have a pretty lengthy disconnection process. So third past due is about 2 to 3 weeks, somewhere in there, before you would get disconnected, which is, like I mentioned, the kind of that lead that the third party currently wants to help out a customer. So the goal to come out of this is to develop a pilot that we can, instead of having these customers go through this program and having it be 2 weeks long, either have them pre-approve or have it expedited through this program to be able to get the verified low income customers through the system quicker. So here we just have a breakdown of who is low income out of everyone who's received a past due notice. Out of those people, how many have already enrolled in our program before, and then where they are in household size. So again, block 2 and block 3 are the biggest groups there. We have that same breakdown for our final past due, which is only about a week before disconnect, or a week before their notice that they're going to get disconnected goes out, and then same thing with the disconnection. So this page kind of ties it all together, and you can see the true breakdown of how many fall through per se. So you start at how many get a third past due, final past due, how many get a disconnect event triggered, meaning that they're scheduled to go out, and then how many of those actually get completed. This is for our entire service area, and then we can come in here and look at just the flow income through Edison and see how many of this. So this was really able to help us look at how many customers we're going to be potentially reaching out to in our pilot program, trying to capture them before they get their disconnect notice. About 3,500 people, and obviously we don't have, the funding to give $250 to every one of those customers. But we just wanted a whole number of what could be the potential customer group that we're reaching out to. And then tying into the conservation part, we don't want to just, like I said, we are in a budget-based rates. So if you're over budget, you're going to be paying more. We want to incentivize customers to have good water use habits and stay under budget, because that's the quickest way you can get under budget and spend less on your bills if you're in tiers 1 and 2. So we wanted to look at people who have already enrolled in our program before, kind of where they fall in, how over budget they were in certain years. So we're looking at 2025 here. We can come in here and look at 2026. You can see that there's a customer that had enrolled in our system, or there's 7 customers that had enrolled in our assistance program, but have also been over budget all 7 months so far this year. So those were ones that we want to have more targeted outreach on and offer them our conservation programs or a home audit, and try to see, is there a leak going on there, or is it just they're watering every day? And that's something we can help them out with to get back under their tiers. Because while we can't provide them $215 every month, if we can stop them from overwatering, which is costing them $250 a month, that's a huge way to get them under budget. Anything else you want to add?
No, we're testing all sorts of different things. We also did late last year, early this year, some targeted outreach to the CARES customer email group, specifically letting them know about both the help to others, any other income assistance programs, our home consultation, which is where we sent a contractor out to do indoor and outdoor evaluation for leaks and recommendations, about our Landscapes for Living program, where they can get information about the particular landscape. Again, we can send someone out to replace their irrigation controller, make minor irrigation system repairs. It also had information about the other rebates that are available through Metropolitan and ours, both indoor and outdoor, all of these kind of things, just to see, and so our intent was, if there was a lot of response to that, we'd maybe do like every other marketing time we do would be to the CARES list, or those on CARES list who are over budget and haven't participated in a program. So we're testing out various different things. I don't think we saw any difference of an uptick from that last e-blast. Maybe it's because it had too much information. So we're testing out different things. We're very on fence of, do we require them to participate in our home consultation, where we're helping evaluate and look for issues? But if they're not the owner, they can't make the changes, And so there's certain things where it's we're on that gray area of, we want to make them do more, so they're using less water, which means their bills are lower. But then also we don't want to inhibit them from being able to utilize assistance when they need them. So it's a weird wall to wall, weird fence to walk. So, but we're all the time. This is a very ongoing, very fluid. If I use the word when we talk about water related things, but very fluid program where we're trying out everything and anything we can. I will also point out that we have been, Wajih, who works in our governmental affairs office, is kind of the one who spearheaded taking this beyond just us talking about it within things. And we have been in talks with the state water board about, once we kind of get some things more nailed down, doing a traveling roadshow where we'll do presentations, probably a webinar series type of thing, where we'll talk about how we've done this. And if any other agencies start doing it, maybe they'll be included, just to help roll it out on a bigger basis across the state. Because talking with a few folks, we're not necessarily the first to do something like this, but we're the first to do this and do it such a concerted effort around it, and maybe looking at not having our own income standards, but just utilizing one that's already there. There's all these partnerships we can have with other utilities with mostly publicly available data. Why not, utilize it? So we're working that out. We do have an SOP about how we did this. It probably needs to be updated though, because I feel like we've changed things. But I do want to flag too with that at the AWACE conference, the Water Now Alliance gave Wajiad Award as a up and coming water leader. I forget what it's called. She was able to make it, but recognizing her for her work around this. So it really is kind of like, I heard a few people say, we kind of do that. I'm like, kind of not doing it. So that's why she got recognized. And that's why it's significant. That's why the state's interested in what we're doing. So, because they can't necessarily give us money for low income the same way we would need. So if we start utilizing programs and partnerships, we can get there. So.
Well, that's great. Thank you. We have a couple of questions online. Let's see. We have the first question is, how do you know the household size? Are you collecting that as customers sign up for service?
So we do have a default that when they move in, because they can sign up online for service, they don't actually have to call in and talk to anybody. But part of their welcome package does tell them, hey, if you're outside of the variance, or out of the standard 3, fill out this variance form and your bill can be adjusted accordingly. So we do collect it. And then when we do get on a call, somebody calls in, we do say, hey, just wanted to verify this information with you. You still have, 6 people in your household? Oh no, now we only have 4. So we'll adjust them there.
And that is a part of our home audit survey that we offer through water use efficiency. That's part of the information we collect, which has kind of brought up the conversation of does that help them? Because if they are listed as 6, but they actually only have 3, now we're lowering their budget even further and trying to get them to use under that. So it's a balance between having them be honest with it, but also not trying to hurt them in the process of while trying to help them out by lowering their budget.
And the yin to that yang is our sewer. We also have a sewer block factor, assuming if there's more people in your house using water, there's more going down the drain. So it does benefit them on the other side of their bill for us to update that number. But yeah, like David said, at every point of contact we have, we try to get that information.
Great, thank you. One other question here. Someone's asking just what's the software called?
So we utilize Power BI. Like David had mentioned earlier, different business systems, mostly our SQL data warehouse, just utilizing the gateway between there and using that as the data source. You can use it through Excel and SharePoint, all this other stuff. It just might not have the best refresh capabilities, but by having it on our, utilizing our data warehouse, we're able to get this on an automated refresh schedule. So most of our reports update daily and sometime between 4 and 7 in the morning. So there's always the most up-to-date stuff. In this case, it's not as important. This is because it's still, in this discussion and not in production yet. We just update it as needed. But for dashboards like Raphael's, it's essential to have the most up-to-date information. But yeah, for all the reporting, we utilize Power BI.
Awesome.
I like to say it means you can do this anywhere you work as long as you have a Microsoft license. So it may not be the same granular level of every 4 in the morning update, but this is something that if your IT gives you access or you're the IT person, it can be built anywhere.
Yeah. So Power BI is free to any users. So you can download Power BI desktop. So you can import, spreadsheets. You can connect to databases if you have the right credentials. The only thing you can't do with the free version is publish. So if you want to share it with other people, then you actually have to have the, a pro license to publish and share with other users. But you can do all this analytics on your own desktop for free.
Awesome. Just one, so I have one more question. Is this a public database that we can connect?
This one is not. This is our internal MWD customer database.
I think our only public facing thing was we have a version of HydroMapper, which is our internal GIS mapping that the public can access on our website. So you can see where, to an extent, where things in our system are. to a publicly safe level of data.
Yeah, I guess one other question just to close out, final question. And that was like, how would you describe maybe the relationship between, like operations and I guess either water efficiency / IT, and has that relationship existed for a long time, or is it something you've built up?
It's a pretty tight relationship. Just from talking to people here and sometimes they're begging for access to databases from their IT department and they're a little bit hesitant. I think having IT work directly with the business and trying to reach that main goal. I mean, I'm on calls with these guys every single day. We're trying to find this data source. How can we get to it? We're putting in the data governance. We're doing the data cleanup. Ryan's pretty efficient with building the models. Raphael, I build the model and he goes to town building reports. But we do work very closely together.
I think that's where the trusted decisions parts come in. Building a reputation with operations, originally the DMA discussion started without them, and we said, no, we need them in here to, tell us about these valves and stuff. And they jumped right on board. We had a little demo set up for them and said, here's what we're trying to accomplish. And they said, all right, let's do it. So I think it really comes down to, being able to show I don't want to use the word ROI, but being able to show the value in the analytics. And they jumped right on board and said, no, this looks amazing. It's going to be a big help once it's built out. So they know they're going to put in the time to get it built out, but they're excited to see what that final product is.
And I'll add too, I think Ryan's only been with the district for about 1.5 years now. And prior to that, while I could have some interaction with David, and there's a gal in another department that would run reports for me and stuff, having him work with our department, talk to my staff, be able to speak our language to the bigger collective has been super helpful. So I think having someone like, he's a management analyst by title, data scientist by practice of what I make him do every day and beyond. But I think having someone who can help represent your department to be part of that relationship to make sure that your perspective is included, because I think like Raphael and David could have had this relationship and done great things, but there wouldn't have been that maybe the water use efficiency perspective that we want to see within this too. So having someone that can help advocate, help speak the language of both the IT side of things and then the whatever department side of things has also been super helpful. Because when I was first getting reports, it was like, here's an Excel thing. And then I would turn it into something slightly prettier in Excel. And then Ryan came and was like, oh, I can get this for you from IT and I can help with the relationship there and build better things for us. So.
Well, thank you so much to the Eastern Municipal Water District team. We have one more presentation. And so I think we're going to be pulling up some additional slides.
Email them.
Yes, yeah. So we're about to pull up some additional slides, but while we do that, I would be happy to introduce Tim Colley with Elsinore Valley Municipal Water District. And apologies.
Caitlin Justin.
Yes.
All right, good afternoon. Thank you guys very much for having us. We appreciate it. Thanks, Jenna, for inviting us back. It is nice to hear kind of the troubles that your guys are having, same troubles we're having, the repeat customers, the non-reading meters, the chewed wires, all the same stuff. But it's nice to hear we're not the only ones experiencing that. You did get to experience on a lot of that. So as he said, my name is Tim Colley. I'm the Water Operations Manager at Elsinore Municipal Water District, excuse me. I've been there about 17 years, 35 in the industry. And we started this adventure on DMAs, probably back in 2010 when we had SCADA data and our AMR data. And we quickly found out that because of those reading routes that we talked earlier, that the data just wasn't going to align. So we had to kind of table our idea until the AMI information came on up and running. So as soon as we get the slides up here, we can figure this out here. So I'm kind of hoping everybody is in this room or online understands what AMI is. So I probably will kind of skip over the first slide here while he's getting that presentation up.
The mouse is very bad.
Yeah, that's all right. Well, while he's doing that, actually, I'll let Caitlin introduce herself real quick.
Caitlin, I'm a fellow at Elsinore Valley. through IREN and WRCOG. So I've been here for almost a year now. Kind of got thrown into the DMAs on like the meter test bench data side of it at first, and then went into helping finish zones and looking through all the data every day.
And let me tell you, she's invaluable. We appreciate it. So, we'll go ahead and go to the next slide. I think, like I said, everybody understands what AMI is. I hope online, but basically it's a meter that's smarter than the old technology. As Raphael said, we had the old school days. You go to that house once a month or every other month, depending on your billing cycle. You'd get one read, and that's all you knew until you got the next. Now we get hourly reads, 24 hours a day. Those are downloaded into our data lake or data warehouse. And then we pull information out of those for various reports. Next slide, please. Our AMR system was installed in 2002, and it was running to the end of its useful life. So in 2015, 2017, we did our pilot program with the Census iPearl. That was our first, stab at AMI meters. Since then, in 2017, we went full implementation, but we wanted to go with a meter agnostic platform. So we went with Aclara. So we can use multiple brands of meters. So currently we have a Micrometer, Neptune, Badger, Camstrup, and Census, but the network is open to other meter manufacturers as long as they speak the Aclara language. And we kind of that was kind of our mindset, because at the time, our AMR system was one supplier, and started to see customer service issues, started to see supply issues, started to see, we weren't their biggest customer anymore. We were just another cog in their wheel. So we wanted to make sure we had some competitive options out there when we went to go buy meters, which was beneficial during COVID. Even though meters were hard to get for everybody, we at least had 4 or 5 different vendors we could go to and see who had meters on the shelf. We also wanted a customer portal, kind of like what you guys showed earlier, and we'll show that a little bit in the next screen. And we wanted some sort of leak detection, but we didn't really know what that was at the time. In 2017, we had 45,000 meters. The radios were installed by a third-party vendor. Now, fast forward to 2026, we're just over 50,000 AMI meters, dropping a bucket again compared to Eastern. But we like to think we can play with the big dogs. But in our AMI system, we are 100% 100% AMI now, all the way across the board. I do have hydrants there at asterisk, because right now construction is so high that we had to pull some of the old non-AMI meters out of retirement and put them back into service. So all of our standard hydrant meters are AMI, all of our source meters, all of our pump station meters are AMI. I think you said you had 22 data collectors. We have 69 data collectors, probably because of the topography, but we also want a triple redundancy. So every meter should be able to see 3 different antennas throughout the district. So if there's an interruption in one tower, we can send that information back and forth to other towers. Next slide, please. So this is our customer-facing portal. This is called Aquahawk. This is what customers can see on their side if they sign up for this application. Currently, we collect 1.2 million records a day, which again is a drop in the bucket, probably to Eastern. And we have over 400 million data points per year. Aquahawk is free to customers. And what's beneficial about that is if they sign up, they can set parameters. So if they have leaks, continuous usage, they can be notified. Probably most agencies have this. They can set up a limit for their bill or usage. If they start approaching $100 and they want to know about it before the end of their bill, they can be alerted for that. But we also get notified for negative usage. We have found numerous meters running backwards. Again, I'm sure you guys see that all the time. Pressure differentials, meters run forward and backwards a small amount. But we actually did find a cross connection from a well. Property owner owned 2 separate properties. Elsinore meter on one property, a well on the other. He decided to tie them together. Meter went backwards. So within a couple of days, we were able to cut that off, do all the proper reporting, and make sure that didn't happen again. And then it helps us interpret customer usage habits, especially when they call in and say, there's no way I use that much water. We can pull up this information and say, yes, you did. Absolutely. So it's really beneficial for them. So Eastern checked on, kind of hit on this earlier. What is a district metered area? It's a hydraulically isolated discrete zone consisting of known points of inflows and outflows. What we use that for is metered entering and exiting all isolation zones, metered at all services within zone. It is kind of sad, but we have sat on other DMA presentations where they are not 100% metered or even AMI, and they're trying to do virtual DMAs with that information. And it blows my mind why they couldn't try that. And we use it for our audit our water loss. But the benefits are to target defined areas and monitor revenue loss. And I'll show you that here in a few minutes. Water loss control. Then the last two, conservation efforts and meter accuracy. To me, those kind of go hand in hand. We know that the meter is accurate. More than likely, the customer will conserve water if they're getting a full bill. And we have a good example of that at the end if we have time. We can show you that. Next slide, please. This is our 10,000 foot view of our hydraulic profile. We cover about 97 square miles. Again, small chunk compared to Eastern, but that is basically our transmission distribution. On the far left, we have our connection with Western Municipal Water District. On the far right, the little pink dot, we have our connection with Eastern. And at the very top, the little blue kind of dam, that's our surface water treatment plant up there. So, and then all the little blue dots within the middle, kind of hard to see in this graph or from this distance here, but those are our wells. We have 14 different wells throughout the system. All that water feeds into that big dark black line around the lake. We call it the loop. So every drop of water that comes into our system goes into that loop system first, then is distributed out to different elevations. Go ahead and click the button. So these are our defined DMAs. Now we are currently 100% DMA. We have 22 zones. All the green ones are individual DMAs. All the red boxes that you see are actually one DMA that are all connected. Even though they're spread out throughout the entire valley, they are connected by one single pipeline, which is that loop. And they're all the same hydraulic gradient, 1,434 feet. But if you look on the left side of the map, you see that big conglomerate of boxes there. It looks like 2, 4, 6 boxes there. I can't really point to it. But to really define a DMA is not a rectangle box. They actually have defined boundaries. So go ahead and click again. So this is actually what that side of the lake actually looks like. You can see all the different zones there in different colors, a loop in the light gray down closer to the lake. But every one of those zones feed into another zone or feed off the loop. So it's not one flat area. So the further you get away from the lake, you're going up in elevation. So that's why we have different isolated zones. But the gray zone can feed the kind of red zone. The red zone can feed the blue zone feeds the orange zone up there to the top left. So we have to account for all that data coming in and out of those zones. Next slide. I'm going to let Caitlin take over these next few slides here.
So these are just a more simplistic way of looking at our DMA zones. Tim likes to say these are our word problems, or like little recipe cards. So this is La Laguna. It's our pilot. It's the first one that they started with. It's the little tiny yellow part that we just saw on the last slide. Everything's measured at the pump station at the base, goes to the customers, and then our storage tanks, every tank in that area is measured on the first day and the last day, and that difference gets put into our production. And everything else that is missing is our loss. And then you go to the next one. And then it gets a little bit more complicated because Ortega here has 2 different sources. We have a well source, and then we're also getting water from the loop through our pump station. Then it goes to the customers, and then because we're also getting water from a well, if the customers don't use everything, then the water circles back and it gets fed into the loop. So it's a supplier for the loop and for the customers. And then everything else is our known loss again. And then you go to the next one. And then loop, which is our biggest one and our most complicated. We have our 3 major sources, our 2 connections, and then our water treatment plant in Canyon Lake. We have all of our other wells except for that one in that other zone. And then when it gets to customers, we have our other zones that are fed off of loop. So we have to subtract all that usage out from their pump stations. And then we also have our 13,000 customers in this zone, and I think it's 12 tanks. You can click the button again. And then it's our known loss again.
Oh, there we go. All right. We're going to go to one of our zones called Horse Thief.
The horse is still in water.
Yeah. And we're going to go back. Caitlin, what's the dates over there?
I give you your paper.
Thank you so much. All right. So we can look at all these different DMAs. You can see all the different dates that we can pick here. So we're going to go back. This DMA has been around for a few years. So this is one of our ones we started off, after the pilot. And one thing, advice I give anybody starting a DMA is, I think kind of our mantra is, we didn't know what we didn't know. And when you start digging into all this data, you start realizing how much you don't know, and you start going, and why is this data not, clicking, or why is it not making sense? And you have to dive in and find out where those errors are. So right here, I'll just go real quick through the dashboards, but here's the water is produced through, goes through the pump station. And just like the other Power BI presentation, you can see the data in the background, and we'll show you just that real quick. So we can look at all the reads for that production meter throughout that time frame that's on that date window that we decided to pick. So right now we're all the way back to 2023 because I wanted to give you a large data set. You see in our reservoirs, what's the difference between the reservoirs on May 14th versus July 1st? They do a calculation with the reservoirs in that zone, plus or minus, depending on if more water went in that reservoir during that start date and the end date. And then that gets calculated into the net. Come down here, the net 1.0 billion gallons of water versus what is sold to our customers. And you can see all the data points in the customers here. Again, I won't spend a lot of time on that for everybody else, but you can just see the data. It starts with the highest user all the way down, which is beneficial to us. So we can take a quick glance of, who's our users. But what's important is this known loss. This is something, again, this is what we didn't know until we didn't know it when we started with that original data set. As we didn't account for a lot of things, the hydrants meters that were in the zone, inaccurate meters, things like that. So you can see back in the day, this is when we had hydrants in this zone that were not AMI. So we had to go in and manually enter the reads into those hydrants for all that time. So you can see all the different things. Here, there's one where we drained the reservoir. So we had accounted for 800,000 gallons in that reservoir. I think there's a couple meter malfunctions in here where a meter stopped working and we had to estimate the usage in there and add it back in, come up with that data. So that's really the background of the data. Is this zone was basically its born on date was 12/2 of 2022. So we don't want to look at any data before that, as any data before that is going to be erroneous. There's 2,195 meter connections in this zone. And then we add this on later on, is our AWWA audit gave us an 18.6 gallon per connection loss as our target goal. So in this zone, we're 8.95 gallons per connection. So we know in this zone, we're meeting that target. But if we had an individual leak in this zone, what would it look like? Also here, we've got this box where we wanted to define it as just under 14 gallons per minute through the entire zone, which is pretty good for almost 2,200 meters. But what we did know is in this zone, we knew we had a leak. We knew exactly where area it was, but it was under 18 inches of concrete underneath an Arizona crossing that was continuously flooded for years. So we could not get in there. So Riverside County did a project here just recently where they went in and tore out that Arizona crossing. We found our leak, and like I said, we knew about where it was, but we couldn't really identify it until we got all the concrete out. Let's see, sorry, I want to go back 1 month here, because that was just fixed in November. May of this year. So we went from 97% to 98.7%. And we have a total loss in this zone now of $2,156 per month. Or I forgot to show that before, it was $3,000 a month. So we gained $900 a month in this zone by fixing that leak. We'll go to a different zone here. We're going to go to Cottonwood. This is over near Canyon Lake. We'll show you Canyon Lake here in a second. We're going to hide that, and we're going to go to a more recent date here because
Wait, I would stay on these. This is this one.
what's that?
I'd stay on these dates,
Okay.
I think. What are you doing here?
Yeah, so here's Cottonwood for July 1 to July 1 of this year. And we're at 99.8% in that zone. And we're only losing $407 a month in that zone. What's unique about this, though, is its sister zone, which is literally across the street. Here we got 3,800 homes. Our 3,800 meters are all residential and light commercial. But if you go to its sister community right across the street, I can get it to click. Canyon Lake, which I think, we bordered up to you guys in Canyon Lake, one of your DMAs. So here you can see it's 94.6%. we're almost $10,000 a month loss here. And we'll tell you why in a few minutes. But we have a speculation on that. And I want to show you one more real quick. I'll go ahead and hide the dollar value here. And we're going to go to one of our smaller zones. And again, the smaller zones tend to give us more trouble sometimes in the data trying to figure out what's going on. So this zone here, Sky Meadows, was 94.6%, but you can see it's only 119 homes. But we still exceed our 18.6 gallons per connection per person. But when you go to see what's that costing us, $421 a month. It's not worth a truck roll. It's not worth meter replacements. It's not worth looking for that loss percentage up there. But we're still above our gallons per connection. One last thing I want to show you before we move on here, get out of that, is we also have a GIS version of this, but unfortunately, because we're here and not at home, I cannot show you that where you had the maps and all your kids. We have something very similar. It's very nice to look at, but if we can also look at all of these DMAs through a scattergram. And we're going to look at Tuscany Hills right here. This was one of our most solid communities for a long time. You can see for April, it was 99.8, 101, 100.8, 101.4. Well, come November of last year, we actually started seeing a decline. But here's the thing: is we didn't see the decline at first because we were working on other things. We were out doing some work at another facility, saw water coming out of the side of the hill. We thought, wow, that's groundwater. It's right by the lake. We took samples of it, no chlorine residual, and started looking around. Well, probably the next day or day later, like, oh, hey, dummy, anybody look at the DMA? Because it's not automated. We had to go in and manually look. At that time, the DMA had gone from 100% down to, right around 90. They're like, hey, there's a problem. So we sent staff out into that neighborhood, and they actually found 3 service leaks in that community. And in March of 2026, we fixed those 3 service leaks. And you can see now it went back up to 99.4 to 99.8. So this zone's pretty tight. We're going to exit out of that and go back to the presentation here.
The PowerPoint.
Oh, yeah, in the bottom.
Oh, that one?
Yeah.
And this is one of the copper services we actually pulled out of the ground. It's at the hydrant nearest to that resident, and you can see how much water was coming out of one service underground. If you can see the dial right there, 39 gallons per minute was going out of that one service leak. Now, what's unique is the house next door had the exact same problem. Then we found a third leak 2 streets away, which was much smaller, but what we think is a other utility went through there and bored through, and they nicked both those pieces of copper. And that's what, basically had that problem. But that's what it looked like on top of the ground. Why that service was leaking at 38 or 39 gallons per minute. Not one drop of water came above ground because of the type of material in this community. It's all rock and shale, so it all basically soaked down to the ground, came out of the side of the hill a half mile away from where it was leaking. Wow. So once we put 2 and 2 together, realized it was a service leak or a leak in that community, went and found it, and but there was no indications on the surface that we had leaked. And
I think that green grass is an indication.
But most of the time our leaks come up because our soil is just rock hard. But in this community, it's more of a shale. So I told you to go back to Canyon Lake and Canyon Hills. You can see the Canyon Hills or Cottonwood on the right for $915 a month versus $12,000 a month loss in the Canyon Lake zone. And what we started doing is looking at a lot of our meter information. And we found out in the Canyon Lake community, 42% of our meters were over 20 years old. We actually had meters over 30 years old, pushing 38 years old in that community. Where in the newer community over on the right, we only had 19% of the meters that were over 20 years old. So, we were starting to figure out, is this a data issue? Do we have leaks? We think a lot of it is a pass-through issue where the meters are still operating, they're still spinning, they're just not reading accurately. Now I'll let Caitlin take this one over.
So this is the average passing rate of all the meters that we pull. Every meter that we take out gets tested at our test bench. So from 2020 to 2020, now halfway through 2026, there's been about 1,000 meters tested this year. So far, in past years, it was the same number. So we're looking at the same sample size for all of these. You can see cycle 2 which is where Canyon Lake is, and cycle 8, which is where Cottonwood is, the passing rates are very, very drastically different. Canyon Lake has not passed more than 30% of their couple hundred meters that we've tested yet. This year so far, we're at a 17% pass rate with like 400 meters tested, something like that. So
That means they passed that based on the MWD standard.
Yes.
98.5.
Yeah, and that's actually in this slide right here. This is our meter test bench data. Unfortunately, this slide's about 2 years old, but it still rings true. I think Ryan mentioned earlier about Raphael mentioned about 20-year meter change out. We're on that same issue. We kind of saw at 15 years where the green arrow is. It was about the last point that we stayed above the AWWA recommendation. But we also know from our years of experience with these AMI units that the batteries only last about 10 years. So we're seeing at best a 10-year battery life so far. So that would, so we moved it out to a 20-year change out where we hadn't quite died yet, where you can see after 20 years, it really started to take a dive. But that would hopefully give us 2 battery change outs as well, in between a full meter change out. So, but what that basically came back to is 37% of the meters in our entire service area are over 20 years old. So we're kind of behind the ball on doing a massive meter replacement program. But with data like this, we are able to get two more FTEs to do just meter change outs. So the board approved 2 people to come in and we're on target to do 1,700 meters per year per person, just of change outs. That's not even on top of the meters that die, the rodents. These are just what we call MCOPS, meter change out program. So that's my contact information to Ryan, who's usually my co-presenter. But if we have a few minutes, I have a couple more slides. Okay. So this one right here, this is one of our test cases. This is on our recycled system. This was a 2-inch meter that was installed in December of 2010. And you can see in 2021, the total bill for that year was $9,144. And so we kind of looked at that as we're assuming that meter was 100% in 2021. We didn't really have a lot of the data to go back. We can now, but in 2021, we were basing it on being 100%. Well, in 2022, we saw a drastic decrease in the revenue coming from that meter. And we can see in July, where you went from $900 the previous year to $247. A meter is only reading 27% of what it read the year before. August, $1,000 to under $300, 27%. September went from $1,400 to $280, 19%. So we think something happened to that meter in July of 2021 or 2022. So you can see we went from $9,000 a month to $9,000 a year. I apologize, to $3,000 a year to in 2023, $1,100 a year. And we think in 2024 they might have got a little smart and said, hey, we can turn up our usage because our bill's not very high. So, or it was maybe a little bit hotter, but we don't know. But all those calculations are also based on our tiered structure and how the rates changed each year after year. So it's not just based on one factor. It changed with each year of our, a rate change. So 2024, this was the very last meter we changed out in December of 2024. So we monitored this meter for all of 2025. And this one meter now made $21,000, almost $22,000 in revenue or billable usage for that 1 year. So you can see it's over double what we thought might be the 100% in 2021. We did reach out to the HOA probably early in January when we tested the 2-inch meter that came out of the ground and found out it was at 13%. But it was still spinning.
Yeah,
it was still spinning away. But we think we paid for a few HOA Christmas parties. But this was just one of their 24 meters that they had. So we went and looked at some of the other meters. None of the others were as bad, but some were in that same ballpark. So, when we're talking lost water in a zone, it's not always just water leaking on the ground. It's those, apparent losses that it's going through the meter. The customer is getting it. We're just not being billed for it. So we could see, big jump from 21 to 2024. We did quick calculation over those 4 years, we lost $40,000 through 1 meter for that time. Last thing, this is a DMA that I showed you guys earlier, horse sieve, where we knew we had that leak. We could see all along here, you can see it's below, it's right here at 90%, 97, 98. Should click on that. Well, we ended up finding that leak, and this is what it was.
How long was it there for?
Years. we knew about it for 2 years before we could get it dug up, but
President.
you can
Remind us
see,
of
you
that.
know, what it was leaking, but we go back, once we fixed it back in May of this year, just, you know, 2 months ago, all of a sudden our DMA came right back up to 100%. And this zone is under heavy construction. We have 4 different developments going on right now. We do have water theft. We catch the contractor constantly, but that's a small percentage of what was going out in just that small leak. You can see it wasn't very big. We calculated through the DMA, it was under 17 gallons per minute for the entire zone. So 15 and a half of them might have been coming right out of that leak. So with that, I know I talked a lot really fast, but that's kind of, I tried to condense a lot of stuff in here. Like I said, we could go through the DMAs. We got 22 of them. We could spend quite a bit of time if you want. Actually, real quick, if you see. You talked about your big one. Let's see. So we, as of just June 1st of this year. Okay, fine. We got our last DMA, which Caitlin mentioned earlier in her presentation about the loop. That's our biggest zone, 13,000 meters. Now it's not perfectly accurate, but it's damn near close for being its first try. With 13,000 meters in this zone, we came in at 103%. That we thought for the first data pull, that was pretty darn good. So we'll go in and define, you know, some of this information, but there was so much data coming in here. You can just see the known losses through here. But we go in and add, you know, a malfunctioning meter right here, 668,000 gallons. Work orders. So Caitlin goes in through all the work orders in that zone and no leaks, hydrant repairs, things like that. She calculates all the water loss through there and adds it back in. So being for like I said, our really first month of our largest zone, which is a culmination of all those other 21 zones, 103% we're not too unhappy about. Now, unfortunately, when I show the dollar amount, we're actually gaining money in this zone. We know that's not correct. So we're working on that. When we were at 90, we did some data in there and we're at 97%. We were about $100,000 a month loss in that zone. So 3% loss in that zone is huge compared to 7 or 10% loss in a much smaller zone, which is hundreds of dollars. So it's, again, that's kind of one of those things we didn't know until we didn't know, because one of the first zones came up in the 80s and we went, oh my God, what are we going to do? And when we put a dollar value to it, it's under $1,000 a month. So it's like, okay, should we waste a lot of time and energy and effort changing out meters in this zone? And what we're going to end up doing now is hopefully getting a software package where it'll help predict, instead of changing water meters in this zone, even though they might be still over 20 years old, that this zone's 99.7, go change the meters in this zone that are 92.7 and give us a better, bang for our buck of where we send our workforce. So, all right, with that, I think I've hit all my talking points. Caitlin, did I miss anything?
I don't think so. I mean, we're focusing most of our MCOPs on Canyon Lake, which is the zone with like almost 50% old meters, but
Question for you,
Yes, sir.
and this is where, I've seen a bunch of DMA presentations and going through what we're doing. In Tuscany Hills, I think is what it was called, where you were losing 38 gallons per minute. How'd you find it? I mean, it was obviously underground. And that's the question, I've talked to like Xylem and they say, oh, it's boots on the ground. Well,
unfortunately, that's what we had to do. We set boots on the ground. They basically pulled every meter box. They stuck a meter key on and listened. Okay. We also have a microphone, but we only have one of those. But we had 3 guys walking through. So they were able to quickly find those 2 that were, pretty large. That was the largest one at 38 gallons a minute. The smallest one was 4 gallons a minute, but they were still able to find it just by listening. We are looking at some cam strip acoustic leak detection. We do have a zone down by Inland Valley Hospital that is notoriously lower than we like. It's in the mid to low 90s, but it's still lower than we like. So we're actually deploying about 250 acoustic leak detection meters in that zone to see if it can help pinpoint potential leak, or do we have other issues?
good. Thank you.
I have a related question to that. So I think I misunderstood something about the why DMAs have to be looped. Because say you have a meter here, meter here, meter here, you're trying to figure out, don't you have a reading on each one? So if this one reads lower, then maybe there's a leak in between them.
We basically, some DMAs are customers of other DMAs. So like the La Laguna that Caitlin pointed out. Let's see if I can go back to that map real quick. Oh, probably not, but yeah, so
Go to the Ortega slide.
Ortega slide.
Yeah, go down to the bottom of the PowerPoint.
That one. You want that one, Caitlin?
Oh wait, it's not on there. Never mind.
Oh.
Go, maybe that one.
So here, La Laguna is actually a customer of Rice. Rice is a customer of Albert Hill over here. So we have to account for that data in between. But if one is extremely off, we're going to be looking for, is that zone somehow leaking back into its parent zone? But right now, knock on wood, they all seem to play nice together. But anytime we have water leaving a zone, like Caitlin said, Ortega goes back to the loop if that zone is too full. So we have a meter that is on that is a customer of one, but a source to the loop. That makes sense.
Also, most like these three, I believe the pressure goes up every time it feeds into a new zone. So it's not gonna theoretically go back into the zone before. So it is closed for the most part.
Because could you strategically place some pressure monitors and know where you're losing that pressure?
We could, and it's something we're
'Cause
looking at.
that's something we had talked about with
Yeah.
some of our meters, that we, kind of spread them out and say, okay, well, I know I drop pressure between these two zones.
Well, that's how we knew on the horse leaf we had a zone or a leak on that zone,
Gotcha.
is we basically isolated sections of pipe until a pressure gauge went.
Gotcha.
And as soon as we figured out where that was, and it happened to be underneath that Arizona crossing that we couldn't get to, that was underwater. But we are looking at different ways to now getting more granular with these. Now, a zone that's 99.7, we're probably not going to spend a lot of money on. It's the 92s or below that we're going to spend some time and money doing acoustic leak detection. Another vendor wants to come out and do a hydrant acoustic leak detection in that same zone to compare their information versus the cam strip meter information. So we'll have the hydrant acoustic leak detection as well at the same time. But again, we're still kind of vetting out all this stuff, trying to figure out, what else can this information give us? What else? There's so much data in here, as you guys know. There might be more things that it can help predict. We're actually going to be looking at water age as well. One of our software vendors says that they can take all this AMI data for each of these zones and tell us how old the water is in each segment of the pipe. And we're going to be looking at that. Our water administrator went ears perked up. He's excited, for nitrification issues and things like that.
Why'd you go and say that? You didn't hear any of that, right?
It's not my department. I won't listen to Chris.
But we're looking at ways to enhance this data even more. But Caitlin's done a
I
great
just want to do
job.
acoustic stuff.
Yeah.
We'll worry about paying the water.
Yeah. Caitlin's really go deep into some of the granular data. We had one meter, a 3/4 inch meter, that lost its mind. A little old lady who normally used 3 to 5 units, all of a sudden used 77 billion gallon.
Yeah, 70 billion.
Yeah.
7 billion gallons in like one day.
Yeah, wow.
And then it continued to grow. I think it got to 105 billion.
Yeah.
By the time it was just the meter was reprogrammed.
You just changed its
Yeah,
unit of measure and
They
everything.
changed it out and it got programmed wrong. Slip of a finger.
Yep, they changed it from, being cubic feet to 10,000 gallons or something like that.
Right.
But not that she got the bill, but we calculated it been $360 million for her bill. I kind of wish it would have gone out to see what would have happened, but we do have meter we have meter malfunctions all the time where they just lose their mind and they're running along, 8 units, 10 units, 8 units, 10 units, 10,000 units, 8 units.
Or they go negative like a million and then come right back up. It's like,
We never
So
see that,
The
right?
eye pearls, we really struggled with eye pearls.
Yeah.
When at some point they just get tired and they lose their mind. So,
Just like all of us. It's okay.
yeah.
They don't get vacations like we do.
No, they don't. But the information has been invaluable. Like I said, it helped us get 2 staff members just by being able to prove to the board of directors, hey, we're losing money in these zones. And we are confident going through these meters. We can do that by the meter test bench data that Caitlin was talking about. We can prove that, hey, this Canyon Lake zone, every meter that we pull out of the ground at best is 24% passing rate or whatever she said. We need to change these out.
I noticed when you were going through the dates, it's like every week. Is that the way you best found those numbers?
No, it's just unfortunate right now because this is all done manually. And everything that you saw was done in-house by our IT department, all of the dashboards, or even our GIS dashboards, which are amazing, but I can't show you guys. But we have to call, hey, Dan, can you do an update? So he'll do it every 2 or 3 days, or if we see something really weird, Caitlin will call and say, hey, can you do an update? So it's literally a click of a button for him. But we're looking to get that automated. That's why we're looking to go to the next step, to have a software that will take all this data and every day at midnight do an update. Dan has a full-time job of doing his other IT stuff. So we're very thankful that IT has really jumped on board. I think you guys talked about IT and operations working together. This was really an operations-driven program that we brought IT into. And once they understood the concept, and they've been fully invested. I mean, we use a lot of their time, a lot of their resources to come up with, these beautiful screens, these, again, all made in-house. We're not professional consultants. We're not software engineers. I'm sure, somebody else will make our dashboards look a little more glamorous, but it gives us all the information we need right now. We think, don't get me wrong. They might tell us, hey, here's more information you didn't know you needed.
You didn't know you didn't need it.
Speaking in terms of, verifying your production meter setups, I understand you guys were using like, Jimmy, I may be referring to it wrong, but I think it's called the DXN Badger portable units. Ryan was telling me.
Well, we have multiple source meters. So we have Micrometer, Badger, drawing blank on the other one. Census, I think, is some of our larger meters. I'll be honest, we've seen
Having some issues with one right now.
well, two or three brand new meters out of the box. Put it in, and one was reading 115%. We didn't know it for 2 years because we were banging our head against the wall with the DMA going, why is it positive? Why is it positive? Why is it positive? It's a brand new meter. Well, we had to come out and test it. It's 115%. So they did whatever they did on their side. All of a sudden the DMA kind of flattened out, and then it went wonky again. So production meters right out of the box, even though they say they're within 0.025% or whatever, we're, like I said, we've had 2 or 3 brand new production meters that are giving us headaches. So again, don't assume that your data is correct just because it gives you a read. And that's what we're finding.
And then also, do you guys have the same program out of the box for your domestic meter, your smaller meter application? Do you put those on your test bench or sample a certain percentage of the population before you deploy them?
Yes, brand new meters.
Yeah,
They break every once in a while. They'll go grab a box out of the warehouse, whatever pallet came in from whatever vendor. They'll run them through the meter test bench and confirm that the tag on the meter is correct. And I don't think we've had too many issues on those. It's more so, after they've been in the ground a few years. And honestly, I wish these things would self-destruct in 20 years. I wish they would, because it would make our job a lot easier, but they keep just dragging along. And unfortunately, we've been trying to work with customer service to have some sort of percentage indicator saying, hey, this bill normally is here. Now it's slowly dropped down. Unfortunately, that's just a lot of work for them. They're too busy answering a phone. All the non-payments, that's where we spend a lot of our time. So they don't have the time and effort to do that. So that's why we're looking for a software that will do that for them and let us know, hey, this meter was here. Now it's doing this.
We've been talking about that exact thing.
Right now, we have IT pull report with meters that have declined in the past 5 years, 1 inch or larger. So I'll go through that and I'll find some, but that's all by hand as well. So it'd be nice to automate it.
Yes.
Are there any questions online? This does only have like 5 minutes.
Oh, sorry, I went long.
No, I think everyone online is thoroughly impressed, I think. They have no questions. You can answer them all.
If they have any other questions, they can reach out to the committee and get a hold of me. I had my slide up there for a minute, but we're always willing to share our information. And
You could also just Google and get his email off the internet like I had to do because I couldn't remember the exact the way it was.
Yeah, but we're always looking to share. And again, we're always looking for that feedback for someone to say, hey, did you think about this? And hopefully it's something we thought about. But, we spend a lot of time in our little conference room going, why is this not adding up? And we find 1 meter or a pressure relief valve, like you said. We have one zone that feeds another zone. Operation guys swear, nope, that valve is off. I know it, it's off. I swear to God, it's off. I drove up there before I got out of my truck. I could hear the water. So as soon as we figured out that isolation, also that DMA flattened out. It's about getting your data accurate before you go start looking for leaks. I don't want to send a crew out looking for a leak in a zone and we'll find out it's just a meter inaccuracy. It's a data problem. So
Then your money lost in that zone just increased. It's not just the water loss side of it.
well, thank you guys for your time.
Yeah,
I
thank
appreciate
you.
letting us share.
Thank you.
Thanks, everyone. Thank you for all of our speakers. Thank you for the folks online. If you enjoyed the session, I'll just do a quick plug for the California Water Data Summit. It's coming up next month, August 19th and 20th at City Club LA. We'll be having lots more presentations and just like this. So great learning opportunity. Hope you join. And thank you, and we'll hope to see you soon.